Hello everyone, and welcome to the Barso Teachers YouTube channel. Throughout the duration of our separation, we want to make sure you stay up to speed on the topics and themes that will be typically covered in your classes. For this video, we will be dividing into fundamental properties of powers. By the end of the video, you will be able to apply the product of powers postulate and the quotient of powers theorem to multiply and divide powers of the same bases. If you are in Algebra 2 in Drew's class, or are living with someone who is taking Algebra 2, you already have the resources you need to make the most of this video, namely your Chapter 7 guided notes packet and your Chapter 7 homework packet. For those looking to learn new skills or brush up on old ones, this video is for you too. Just grab a paper and pencil and follow along to this video. Feel free to pause the video and take a moment to make sure you have your packets or some paper and pen now as we dive into the do now. So for this do now, what I want you to do is solve the following problem in two ways. So I want you to first use the order of operations, PEDMAS, remember parentheses, exponents, divide, multiply, add, and subtract. Then for the second way, I want you to expand each term raised to a power by its equivalent. So for example, if you have 7 to the power of 4, I want you to express that as 7 times 7 times 7 times 7. Right, so I will give you some time now to do the following problems. Now that you've had some time, let's go over the problems together and find the answers. So for the first problem, we had 2 squared multiplied by 2 cubed. The first way to find out the answer is by using the order of operations. So we can do 2 squared, which equals 4, and 2 cubed, which equals 8, and multiply the two answers to get 4 times 8 is equal to 32. The second way to do this problem is by expanding out the question. So we have 2 squared, so we can express this as 2 multiplied by 2, and we have 2 cubed, which we can express as 2 multiplied by 2 multiplied by 2. When we do the products of these, we get 2 times 2 multiplied by 2 times 2 times 2, which equals 32. For the second problem, we can yet again use the order of operations where we do 3 squared, which equals 9, and 3 to the power of 4, which equals 27. Then we multiply the two products to get 243. The second way is similar to the first time, expanding the problem. So for 3 squared, we can express that as 3 multiplied by 3. And for 3 to the power of 4, we can express that as 3 times 3 times 3 times 3. Then we multiply the two products. This would be the same as multiplying 3 6 times, which would be the answer, which is 243. For question 3, we have 10 to the power of 1 times 10 to the power of 3. For this one, we can yet again use the order of operations where we do 10 to the power of 1, which equals 10, and 10 to the power of 3, which equals 1,000. Then we can multiply the two solutions to get 10 times 1,000, which equals 10,000. And in the second way, we can expand it where 10 to the power of 1 is equal to 10, and 10 to the power of 3 is equal to 10 times 10 times 10. Then we put it together so that we get 10 multiplied by 10 times 10 times 10 is equal to 10,000. As you can see in the 3 problems, it doesn't matter which way you do the problem, it will result in the same answer. Now that we have gone over the do now, let's dive into today's lesson, which will begin with the product of powers postulate. If you have the Chapter 7 unit guide, turn to sections 7.2 and 7.3. If you don't have the guide, remember you can just follow along with paper and pencil. Let's dive in. So, the first concept we're going to master today is the product of powers postulate. In addition to being a tongue twister, the product of powers postulate is a useful concept with applications in biology, chemistry, physics, and business. As I said earlier, there's nothing to be intimidated about this concept. Matter of fact, you probably already know about 2/3 of it. Products, as you remember, are the answers to multiplication problems. Powers is another way of saying exponents. And finally, postulates you probably don't know, but a postulate is also known as an axiom. It's a statement which is taken to be true without proof. So combining these 3 keywords, we know that the product of powers postulate will be a true statement of the relationship between exponential terms that are multiplied together. Let's put the product of powers postulate in its general form before we apply it to its specific examples. Let's continue by starting this statement. So the product of powers postulate states that for any non-negative base b and non-zero real exponent m and n, or any non-zero base b and integer exponents m and n, then b to the power of n multiplied by b to the power of n equals b to the power of n plus n. From this definition, we have 3 variables to define. The variable b, as we see here, represents the base value. Note, for the product of powers postulates to be true, the base value, the b variable, needs to be the same for each term you are multiplying. So for example, you can only multiply 2 squared multiplied by 2 cubed. The base b for that example would be 2. The variable m and n represent the values of the powers to which the base values are raised. Now that we've defined the variables of the postulate, let's dive a little deeper into what it's actually telling us. The basic idea of the product of powers postulate is that when you have values with non-zero-like bases, you simply add the values of the exponents, defined as m and n, while keeping the base value b the same. Let's do an example to demonstrate the products of powers postulate in action. Okay, so let's look at example 1. We have 2 cubed multiplied by 2 to the power of 4. What we have to first do is identify the 3 variables that we have. As we can see, b here is represented by the number 2. M, as you can see, this m corresponds to the number 3. For n, it corresponds to this n corresponds to the number 4. So we have b to the power of m, which would be expressed as 2 to the power of 3, multiplied by b to the power of n, which is expressed by 2 to the power of 4, equals b to the power of m plus n. So that would be 2 to the power of 3 plus 4, which equals b to the power of 7, which is 2 to the power of 7. All right, so let's break down this problem so that we can see why it works in this way. So we have 2 cubed multiplied by 2 to the power of 4. Now remember, 2 cubed is the same as 2 times 2 times 2, and 2 to the power of 4 is the same as 2 times 2 times 2 times 2. So when we do 2 cubed multiplied by 2 to the power of 4, it's the same as doing 2 times 2 times 2 multiplied by 2 times 2 times 2 times 2. Let's count the number of 2's that we have. We have 3 2's multiplied by 4 2's, which is equal to 7 2's. If you have 7 2's, that is the same as writing 2 to the power of 7. All right, now let's start on example 2. Here we have 10 to the power of 4 multiplied by 10 to the power of 8. Now, yet again, we have to identify the 3 variables. So b is represented by base 10, as you can see here. Then we have m, which we can find here, which is the number 4, and n, where 8 corresponds to the variable n. So by following this along, we know that 10 to the power of 4 multiplied by 10 to the power of 8 equals b, which is 10, to the power of m plus n, which is 4 plus 8, which equals 12. So 10 to the power of 4 multiplied by 10 to the power of 8 equals 10 to the power of 4 plus 8, which equals 10 to the power of 12. Now that we have gone over 2 examples, you should be pretty comfortable with the product of powers postulate. Remember, if you're not, you can pause the video and re-watch it and follow the steps again so that you get a little extra practice. Now that we have finished the product of powers postulate, we are going to move on to the quotient of powers theorem. This is very, very similar to the product of powers postulate. So the quotient of powers theorem states that for any non-negative base b and non-zero exponent m and n, or any non-zero base b and integer exponents m and n, then b to the power of m divided by b to the power of n equals b to the power of m minus n. Now, just like the product of powers postulate, for the quotient of powers theorem, the variable b represents the base value. Note, for the quotient of powers theorem to be true, the base value, the b variable, needs to be the same for each term you are dividing. So this b must be the same as this b. The variables m and n represent the values of the power to which the base values are raised. The basic idea of the quotient of powers theorem is that when you have values with non-zero like bases, you simply subtract the values of the exponents defined as m and n, while keeping the base value b the same. Let's do an example to demonstrate the quotient of powers theorem in action. Let's start with the first example for the quotient of powers theorem. The first example is 10 to the power of 12 divided by 10 to the power of 4. Let's begin by identifying the first 3 variables, b, m, and n. Try and do this on your own this time. As you can see, the variable b is 10 here, as it is mirrored here. This b is the same as this 10. And you will notice that it is same 10 for both b's. Our variable m is represented by 12, and our variable n is represented by 4. So what we want to do is fill in these variables with the new numbers. We will get b, which is equal to 10, to the power of 12 minus 4. The result will be 10 to the power of 8. Now we have example number 2, where we have 12 to the power of 8 divided by 12 to the power of 3. Yet again, we will begin by identifying the three variables b, m, and n. As you can see, b is represented by 12, m is represented by 8, and n is represented by 3. Now we fill this equation out by substituting the variables for the numbers represented here. We would get 12 to the power of 8 divided by 12 to the power of 3 equals 12 to the power of 8 minus 3. 8 minus 3 is equal to 5, so we get 12 to the power of 5. Let's break down example number 2, and let's see why 12 over 8 over 12 over 3 equals 12 over 5. Similar to the do now, what we are going to do first is expand 12 over 8. 12 over 8 can be written as 12 multiplied by itself 8 times. Here we can count. We have 12 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. 12 over 3 can be rewritten as 12 multiplied by itself 3 times. 1, 2, 3. Now remember, it is 12 to the power of 8 divided by 12 to the power of 3, which can be written as this. We have 8 12s on the numerator and 3 12s in the denominator. What this means is that we can cancel out 3 of the 12s in the numerator with 3 of the 12s on the denominator. This means we are left with 5 12s in the numerator, 1, 2, 3, 4, 5, which can be expressed as 12 to the power of 5. Now that we have finished going over the products of powers postulate and the quotient of powers theorem, let's do some more exercises so that you can get some extra practice. I want you to pause the video here so that you can work out the problems on your own and resume the video once you're ready to begin going over the problems together. Let's look at the answer for question 1 together. Here we have 7 to the power of 9 multiplied by 7 to the power of 11. The first thing we have to make sure is that the bases are the same. Here we can see that b equals 7, and here b also equals 7, so we can go to the next step. The next step is to check if we are multiplying or dividing. As we can see, we are multiplying here, so we want to use the product of powers postulate. So what we have to do is we know that b to the power of m times b to the power of n equals b to the power of m plus n. So what we are going to do is add m plus n, 9 plus 11, to get 20. So the answer we should get would be 7 to the power of 20. For the second problem, it is very similar, but as you can see, we are dividing instead. So yet again, we have to check for common bases. Here, b equals 190, and this, b also equals 190. Instead, we are dividing, so instead of using the product of powers postulate, we have to use the quotient of powers theorem, which states that b to the power of m divided by b to the power of n equals b to the power of m minus n. So we would do m minus n, which is 30 minus 12, which gives us 18, and it will be 190 to the power of 18. For the third problem, it is a little different, as we are given b, we are given m, but we are not given n. So here we have to use a little algebra. As we can see, we have common bases, and we are multiplying, so we can use the product of powers postulate. So we know that 3 plus n equals 10. We can use algebra to know that 10 minus n equals 3, so n must equal 7. So we can say b, which is 14, to the power of 7 is the answer. Finally, we have question number 4, where we have common bases yet again, 5 and 5. We are not given m, but we are given n. In this case, we know that m minus n equals 3. So using algebra yet again, we can say m minus 6 equals 3. So we can know that m must equal 9. So the answer is 5 over 9. Hopefully you got these questions right. If not, go back again through the video and try and work it out and get a second attempt in so that you can feel comfortable with these problems. And here is the homework. So for people who have the worksheets, it is 7.2 to 7.3, and I want you to do these homeworks. Even if you do not have the guided note sheets, I want you to give an attempt using paper and pencil, and hopefully you guys will be able to get these problems. I want to thank you guys for joining today. Your knowledge and command of the properties of power should now be improved as a result of your participation. Please check out the links in the description to access useful websites, videos, and supplementary information that will further strengthen your math skills. Don't forget to subscribe for further updates and videos that will help you stay sharp and prepare you to smash those competencies when school starts back up. Bye for now.